It worked. You tested it, the event came in, the order got created, everything passed. Then it went to production, and one afternoon, the same order got charged twice. Segment measured this at production scale. About 0.6% of the events they ingested were duplicates of events they had already received. At 100,000 events a day, that's 600. It starts with 4 things, in this order. What your provider actually promises. Why adding retries first makes it worse. What safe to run twice really means. And where the check has to live. One line carries all of it. Make it safe to run twice before you add a single retry. Nobody is broken when this happens. The duplicate is the documented contract. The mechanism is one sentence long. A sender that hits a network error cannot be sure whether the error happened before or after the message was committed, so it retries, the correct response to an unknown outcome. AWS says standard queues ensure at least once message delivery, and more than one copy of a message might be delivered. Kafka says it guarantees at least once delivery by default. Stripe says webhook endpoints might occasionally receive the same event more than once. Now read that SQS line to the end, because the second half is the part that lands on you. Standard message queues are suitable for various scenarios, as long as your application can handle messages that might arrive more than once or out of order. They hand you the duplicate, and they hand you the responsibility with it. Exactly once is real. It's also bounded. It works inside one system and stops at its edge. Kafka's own documentation puts it plainly. Many systems claim to provide exactly once delivery semantics, but it is important to read the fine print, because sometimes these claims are misleading. So read it. Kafka's exactly once covers reading, processing, and writing data on Kafka topics. For other destination systems, it generally requires cooperation with those systems. Google's PubSub ships a feature literally named exactly once delivery and documents that a subscription might still receive multiple copies from publish-side duplicates. So the honest line is not that exactly once doesn't exist. It's that exactly once effects exist only inside one transactional boundary, and an endpoint sitting in your service, writing to your database, calling somebody else's API is outside it. The standard advice is correct, in the wrong order. Add retries with backoff and jitter, then a dead letter queue. Backoff and jitter only change when duplicates arrive. A dead letter queue catches what already failed. Neither makes an unsafe handler safe. The retry multiplies. Idempotent is the word for safe to run twice. RFC 9110 permits a client to automatically repeat a request with an idempotent method after a communication failure, since the intended effect of the request should be the same. Permission to retry comes from idempotency. AWS puts it service-side. Idempotency makes it easier to retry without fear. Bolt retries onto an unsafe handler, and you haven't built reliability. You've built a duplicate amplifier. You don't make it reliable by retrying it. You earn the right to retry it. Idempotent doesn't mean it only runs once. It means running it twice leaves you where running it once did. The intended effect of several identical requests is the same as for a single such request. The shape that gets you there is deflationary, a processed events table keyed on the message id. You insert that id in the same transaction as the work. If the message was already processed, the insert fails on the primary key constraint, and the duplicate is safely discarded. And you still return success, not an error. In Postgres, that's a unique constraint and an on-conflict do nothing, which the docs describe as simply avoiding inserting a row. That's the whole mechanism. No broker, no framework, no platform. A table with a unique column and an insert you let fail. Every time I have watched this go wrong, the team reached for infrastructure. The answer was a column. Check whether you've seen this id, then do the work. That isn't a guard. That's a race with a comment on it. 2 deliveries land in the same millisecond. Both read not seen, both do the work, both write the key. AWS's reliability framework spells it out. Maintain consistency and atomicity with locks or transactions, and that includes recording the idempotent token and running all mutating operations associated with servicing the request. The Builder's Library article on making retries safe with idempotent APIs says it in one clause, an operation that combines recording the idempotent token and all mutating operations. Their token is our dedup record, one atomic unit, both or neither. If the dedup record can commit without the effect, or the effect without the record, you've built the race back in. That's the for. Now the parts nobody warns you about. Two credible sources disagree here, and the one you're most likely to find first is the one I wouldn't follow. The standard webhook specification says to use the webhook id as an idempotency key, and suggests saving the ids in rediz for 5 minutes. AWS well-architected, the Builder's Library, the pattern catalog, and Postmark all say write the dedup record atomically with the work itself. Those are different guarantees. A cache forgets. When it fills up, when the process restarts, and when two workers race. Then there's the arithmetic. Stripe retries for up to 3 days. A 5-minute key cannot cover a retry that arrives on day 2. So the durable record is the correctness mechanism, and a cache is a fast path you put in front of it, never instead of it. Dedup on the provider's event id. Good default. And 2 of those providers document where their own id is the wrong key. GitHub's delivery header stays the same across a manual redelivery. Exactly what you want. Slack's event id is globally unique. But Shopify documents that more than one subscription to a topic gives you a separate delivery each, with a different webhook id for one event. And Stripe documents cases where 2 separate event objects are generated for the same change, and tells you to key on the object id in the payload with the event type. So the rule isn't the header. It's a stable identifier for the business event, chosen after reading that provider's docs. Put it inside the transaction, still holds, for state you own. The first time your handler calls something outside, you need one more move on top of it. Brander Leach, who wrote Stripe's idempotency layer, splits the handler into phases. The local work goes in a transaction. He calls that an atomic phase. The outside calls sit between them, foreign state mutations. After each one, you write down where you got to, a recovery point. And every atomic phase commits before the next outside call. His sentence is the one to keep. Once we make our first foreign state mutation, we're committed one way or another. We've pushed data into a system beyond our own boundaries, and we shouldn't lose track of it. So the handler becomes a small state machine. Local phase, checkpoint, outside call, checkpoint, local phase. Stripe requires a successful status code before any complex logic that could time out. GitHub asks for a success response within 10 seconds, and a queue so processing doesn't block later deliveries. Slack gives you 3 seconds. Shopify gives you 5 seconds for the entire request. Don't average those. The spread is the argument. At 3 seconds, inline business logic isn't unwise. It's structurally impossible. But acknowledge before the event is durably recorded and you lose it. The sender believes it delivered and never retries, which is why the ACK comes after the durable write, not before it. Verify, persist, 200, then process asynchronously. Stripe retries for up to 3 days, Shopify 8 times over 4 hours, Slack 3 times. The dead letter queue, where a message lands after it's failed every retry, has a trap. On a standard queue, its clock never resets, so give it a longer retention than the queue it came from, or your evidence expires without a sound, and keep the raw event. You can't replay what you didn't store. Verifying the signature and deduplicating the event answer different questions. Neither covers the other. The signature is a keyed hash over the raw request body as received, so a framework that reserializes the JSON before verification breaks it. Compare it in constant time. GitHub says never a plain double equals, but a captured request that was validly signed still is. Only the timestamp bounds it. Stripe and Sphinx default to 5 minutes. The spec file's a malicious resend beside a network retry. Your dedup record was always a security control. 3 things. At least once is what you have, and the provider says so. Idempotency is the precondition for retrying, and the dedup record belongs in the same atomic unit as the effect. This was never a webhook problem. AWS Lambda's docs say the business logic inside your steps must be idempotent, and that event source mappings did not support idempotency at launch. That's the queue to function wiring. Kafka consumers, the same. The machine writes the happy path in a minute. What it can't know is that the provider will send that event twice. So before the retries, before the queue, before the dead letter queue, make the handler safe to run twice. That's the glue, and the glue is the job. Thanks for watching. If this moved one handler from hopeful to safe, pass it to somebody who's about to bolt retries onto a webhook. Subscribe to AI Tech Book and make it safe to run twice before you add a single retry.